Hi, welcome everyone to Xamarin University and to our IOS230 recording. This is our Maps and Location class recording, and I'm Jason DeBoover. I'll be your host while we discuss maps and location. Let's get started. We'll start by exploring our iOS mapping options. Then we'll look at using our location data, adjusting the viewport of our map, and then finally adding annotations. Those are the little pins that we can use to point out points of interest in our maps. Okay, first up, explore iOS mapping options. As part of this, we'll look at adding a map to our app, configuring the map, and then controlling the interactivity of the map. That's things like zooming and rotating the map. Most of us probably already have a fair intuition that maps can be really useful to our users. If we're just showing any kind of address information, any kind of location information, then being able to make it more meaningful to our users by plotting it on a map rather than just showing dull text addresses really helps make our app feel polished. It also can add additional utility that our app might not even have without a map. Maybe we want to be able to do point-to-point navigation, do virtual tour guides, or just show the user where they are in the world. That's things that we can do with a map that we might not be able to do any other way. Now, the easiest way to take advantage of maps within our apps is to actually just launch the built-in map application. It's not going to be quite as interactive and it's not going to be quite as smooth an experience, but if we want to get up and running quickly and it's not a core part of the functionality of our app, it's really easy to just open up the external map application. We just open up a URL with this scheme right here. We can even do a lot of things besides just showing a frame. We can show directions, for instance. There are a lot of other things we can do just with opening up URLs and opening up the external map app. But if we really need and really want to have that full functionality of having a map built right into our app, then MapKit's going to be the way to go. We can add maps through MapKit to our apps, either through code or through the iOS designer, much like many of the tools that we use in iOS, right? So to add it through code, we're going to instantiate a new instance of MKMapView. We'll pass it the screen bounds in order to obviously give it some real estate. Now, of course, if we're going to be moving our screen around, rotating it, using it on different size devices, we're probably going to actually want constraints rather than just static bounds. But for right now, we've instantiated it with some static bounds, and then we've added it to our root view. On the other hand, if we want to add our maps through the designer, that's as easy as dragging it from the toolbox and dragging it onto one of our views. Either way we add our MKMapView, we're going to have several properties we can use to control how it looks and how interactive it is. We can change the map style. We can change the level of detail shown and of course the interactivity, like whether or not the user can zoom it in and out. All of these are driven through properties, and those properties are also available through the designer as well as through code. For map style, we have several options available. Standard, that's a road map. Our satellite view, that's obviously a view of the world from a satellite. A hybrid, which is our road map overlaid on top of that satellite view, and then we even have flyover and hybrid flyover options available. Now, all of these images, all of this mapping tile data is downloaded directly from Apple's servers, and that means for this to work, you will need an active network connection. We can also change the level of interactivity available to our users, so scrolling, whether or not the user can move around the view frame. Rotation, whether or not the user can twist and change whether north is on top or whether some other direction is the top of the screen. Whether pinch to zoom works. And even whether buildings are available to be shown if we're close enough to see them. If we turn all of these options off, essentially what we're giving the user is a static view, almost like a printed map where they can't move or interact with it at all. But we can turn on or off these options independently through code. As you can see, we have several options available here. All of the ones that we just mentioned are available to be enabled or disabled. The map type has an enumeration we can use. And we also have access to all of these properties through our designer. The map type and all of those booleans for interactivity. And now it's time to see some of this in actual code while we do our first exercise. We'll start out this first exercise by creating ourselves a new solution. iOS app, single view app. You can of course be using Visual Studio as well, that'll work just fine. But here in Xamarin Studio, this is how I do it. A single view app, and I'll just give it a name here. We'll call it Map App. And support iPad, iPhone. Target iOS 9.1 looks good to me. Let me just put this in my Xamarin Courses directory. And everything else should be fine for this demo. Okay, now that we have our template created, we're going to jump right in with editing our storyboard. We've already, of course, got a single screen and a single view controller created as part of that single view template. Let me just modify the zoom a little bit here so we can see. And now the first thing I'm going to do is add a toolbar. We're going to add a toolbar and a map to this app. Get that down here, line it up with my guidelines so that it's at the very bottom. And then highlight that, just make it fit the entire bottom. And then I'm just going to also constrain it so that it makes sure that whatever size screen we're using, we're always having a toolbar that fills up the complete bottom. Pin that to the left side of the parent. Pin this to the bottom. And then pin it to the right side of the parent. It has an intrinsic height, so we won't worry about having to deal with a height constraint. And I can always check my layouts here, make sure I like them. Super view, super view, super view, all trailing space, bottom space, and leading space. Looks perfect to me. So now I can add my map as well. Now my map's going to fill up the entire rest of the screen, even right up underneath that carrier bar there. All right, let's zoom in a little bit here to make sure I can get that right to the top of the toolbar. Of course, we'll set some constraints on this as well. I'll go ahead and attach the map to the toolbar here, and then to the left side, to the right side, and to the top. Let's check out our constraints. We've got top, we've got trailing, we've got top to toolbar and top to super view, so we'll have to modify that a little bit. And let's make sure we get our leading space one in here as well. That didn't quite take, did it? All right, there we go. Those look good. Now let's modify this one. So we've got our toolbar top to our map view bottom. We actually want to reverse those. So let's go ahead and just grab this and say reverse first and second item. We also notice that we have a constant here. That means I didn't quite line them up perfectly. So what I'm going to do now is actually just take my map view here and change its size ever so slightly. And then we can modify that. Now everything lines up perfectly. So our constraint and our actual frame that we're using to paint our designer also agree that our map and our toolbar are perfectly aligned. So now everything should work just fine. We're going to go ahead and debug to make sure everything's lined up correctly and looks good on a device, or at least on an emulator. Okay, that seems good. Scroll around, everything looks good. Of course, I can click my items. Our corners are all covered. Now we'll add some buttons to our toolbar. We've already got a default one there. So I'll start by just modifying its text. And we'll make this our standard button. It's going to show our standard map type. Let's go find some more buttons. A bar button, actually. And this one will be our satellite button. In fact, let me go ahead and give that a name of satellite button. And that one will, of course, be our standard button. And then finally, we want one more button. And I'm going to call that my hybrid button. And now we need event handlers for these buttons, and we can use any of our standard methods for getting event handlers. We can use the Events tab. We could go ahead and create outlets, which technically I already did by giving them names, and we could use those to code an event subscription. However, I'm going to use the laziest approach by just double-clicking on these. And I'll add an event handler for that one. And for that one. And for that one. All right, and finally, I'm going to need an outlet for my map so that I can use these buttons to actually change map properties. And I'll just call that creatively map. And so now we're just going to write some code to have these buttons actually change what type of map we're using. So map.mapType equals, in this case, standard. Map.mapType equals satellite. And finally, map.mapType equals hybrid, of course. Let's just go back, make sure our map options are all set correctly. Everything except user location check, that is exactly what we want right now because we don't currently have permission to actually show or detect the user's position. So we're going to look at that in later exercises. Right now, everything is exactly like we want it. And so we've got our standard map. If I click satellite, there's our satellite. If I click hybrid, we'll go ahead and zoom in a little bit. With our simulator, we can zoom in by using the Alt key or Option key on your Mac. That simulates two-finger touch, and you can see when I zoom in, we can already see state boundaries, and now we can start to see roads coming in overlaid over our satellite map. So that's the hybrid, shows both some map structures as well as showing the satellite view. All right, all of our buttons working exactly like we want them to. If we go back and disable some of those options on our map, whoops, we didn't want to drag that map, did I? We can disable zooming, disable scrolling. Maybe we'll leave rotating on just for fun. See how that changes our ability to use this map. So I can no longer scroll. I can no longer zoom, but I can still rotate. So I can change the heading. We've now seen how we can add our map views to our apps and configure them for the style and interactivity level that we want. So now let's look at location data. Here we're going to touch on a couple of things. First, we'll talk about the built-in location services provided by iOS, and as part of that we will have a little talk about the security policy applied to location data, and finally how we can add location information to our maps. Core location is the name of Apple's framework that provides us this coordinate-based data and heading data. It taps into the GPS, the Wi-Fi, the compass, all sorts of hardware on your iOS device in order to get us a standard and consistent API to get location data. CL Location Manager is the main class we're going to use, and this is what we're going to use to be able to get things like our current location. You can also use it to monitor location changes, to monitor heading changes. You can use it with geofencing, beacon regions. Now we'll only be looking at current location in this class, but be aware that Location Manager provides several of these other location-oriented features. In addition, for this class, we're going to use Location Manager in combination with MapKit to display our location on the map. Keep in mind though, these are independent frameworks. We don't have to use them together, but when we do, they make for quite a useful little combination. So to use our CL Location Manager, we're first going to instantiate it. We'll set our desired accuracy. Now this is going to determine whether we're using coarse or fine, and it's going to help the hardware determine what approach and how much energy it's going to use. So if we don't need too much accuracy, then having a larger number is going to help us conserve battery. The next thing we're just going to do is update our UI with the Location Manager's current cached location. Now this might be null or out of date if the Location Manager hasn't been used recently or the device was just powered on. But if the Location Manager actually does have a good cache location, then this is going to help us bootstrap our screen nice and quickly with a relatively valid location. At least it's going to be more valid than just some random location out there in the planet. Then, in order to get our ongoing and really updated and really accurate locations, we're going to start listening on our event. That's the locations updated event. Now, of course, we're only going to be able to get any actual updates if location services is enabled, so we're checking that. Then we start listening on the event, subscribing to that event, and then we'll call start updating location in order to start actually getting these updates. And once that event gets raised and our subscriber is called, we're going to get a CL locations updated event args. And importantly, this contains an array of CL location objects. Now, we actually get an array of CL location objects because it's possible that our onLocation changed event was not called every time a location update was available. In that case, they will actually be batched up and we'll get an array of multiple location objects. In all cases, the most updated or most recent location object will be the last one in the array. And of course, there may be situations where you need to look at each and every location update that you got. But in many cases, just using the most recent one will be sufficient. So you'll be able to just do like our slide here and grab the top one. Then, of course, update your UI with that new location object. The location object contains many useful and relevant pieces of information about our current location, like obviously the lat-long coordinate. It contains our level of accuracy of the lat-long coordinate, our altitude, our course or our heading, that's what direction we're moving in or facing, and our speed. In most cases, it's okay for us to let iOS decide if location updates are likely, and if it decides they're not likely, it will go ahead and power down or go into a power saving mode where we're not using as much energy as we'd be likely to use if we were listening actively to our location updates all the time. Now, if we are in an app where accurate and timely updates are vital, we can turn off this optimization with this property right here, pauses location updates automatically, and set it to false. And then we'll get each and every update and we'll be listening for each and every update the entire time, even in situations where iOS thinks it's unlikely to get an update. The trade-off here, of course, is we're going to use a lot more battery. Obviously, knowing the device's location often means that we know where the user of the device is, and that is considered private information and therefore falls under the privacy policy. It also means that iOS is going to ensure that the user knows we're tracking their location. They're going to do that through a prompt that's shown the first time we access location data. Now, at that point, the user's also going to have the opportunity to disallow us using that location data. And if they disallow us using that location data, our API requests to the location APIs will fail. Starting in iOS 8, we have two different types of location data we can request. We can either request to be able to access the user's location or the device's location when the app is in use, when it's in the foreground. Or we can request to be able to have access to the user or device's location all the time, even when our app is in the background. This started in iOS 8. Before that, we were just able to request device permission, period. With iOS 8, we have to choose, are we requesting permission when in use or anytime? To request the when in use permission, we're going to use the logically named method request when in use authorization on our location manager. Now, remember, this is only available and only necessary in iOS 8, so we're going to use the check system version method to make sure we're running on a device that has at least iOS 8 installed. On previous versions of the operating system, the user would get the pop-up asking for permission whenever we accessed the Location Manager API. Now, when we want to request always permission, it looks almost exactly the same, except the name of the method is request when always authorization, which is a slightly awkwardly named method, but does do the job. We have only a small amount of control over that alert dialog that iOS shows requesting user location permission. We exercise that control through the info plist and some keys named NSLocation when in use usage description, of course if we're requesting when in use authorization, or through NSLocation always usage description if we're requesting always use authorization. Either way, we're going to open up our info plist, add or modify the appropriate key, use the source tab in your info plist editor, and then once we've changed that value, we're going to see that the pop-up that comes up requesting location permission includes our text. Now, of course, it includes our text nice and tiny. Mostly it includes very large text from iOS telling the user that we're looking to access their location data. But our little text allows us to provide that user a little bit of context as to why we need their location information. Okay, so now it's time for a quick flash quiz. Which method requests permission from the user to use location data only when the app is running in the foreground? Is it A, request when in use authorization, or is it B, request always authorization? And that one is A, request when in use authorization. Okay, question 2. The CL location's updated event args is passed an array of location objects. Which one is the most current? The first one, the last one, or it's a Highlander, there can be only one? And for that one, it is the last one. So the user's been shown this dialog asking, would they grant our app permission to access their location data? How do we actually find out what the user said? Well, the answer is we subscribe to an event. The event on our location manager instance is going to be authorization changed. As it happens, this event will also be raised in the event that the user actually goes and changes the settings through the settings panel, changes the authorization level through the settings panel. If our app happens to be running at the time, this event will be raised then as well. So what about in future runs? So in future runs, the user's already changed the setting. The setting already is what it is. So when we open up our app, when we bootstrap our app, we want to be able to check. We want to be able to find out, do we have permission to access location data? Will those API calls succeed? And for that, we can use the CL Location Manager status. And if it's denied, well, then we've got some other things to worry about. But if it's not, then we can go on using our location APIs and everything should be fine. So what if it is denied? Well, if it is denied, we really don't ever have the opportunity again to show that alert dialog, the one that was displayed through iOS where we could control the tiny text there in the middle. We don't really ever have the opportunity to show that again. And so we have to handle things differently. We can beg the user, please go into your settings and please change this setting. A lot of times the way that's handled is to back off a little bit. If location data isn't key to your app, if it isn't absolutely necessary, back off a little bit and start providing the user with some value, and then revisit after the user's used your app 5, 10, 25 times and say, hey, you know what, now that you realize my app provides value or this app provides value, why don't you go ahead and think about giving us your location data? And then at that time, you'll show them exactly how to do it. Fortunately, as of iOS 8, there's a slightly easier way to do this. We can actually open the settings panel directly to our app's location settings, or at least our app settings, and from there direct the user to just tap location and then select the settings that we need. So as long as the user is willing to do that, this is a slightly less onerous way and a slightly less heavy way to get the user to actually make this change. Our iOS maps actually have built-in support for showing the user location or the device location. We just need to set show user location to true or check the user location checkbox in the designer. Be aware, however, that we do still require the permissions that we would set up through core location. So we still need to request the when in use or always use permission. Before we go into our next exercise, a quick helpful note about our simulator. We can simulate GPS locations by going to the debug menu and then the location submenu, and then we can simulate a variety of GPS location paths. All right, now on to that individual exercise. Okay, we're going to be modifying the code from our first exercise. This time we want to add the user's location to our map. So the first thing we need to do is request permission. So let's open up our view controller. And in our viewDidLoad method, we can actually add the permission requests, but we're going to need a location manager. And that I'm going to actually make field level. The reason for this is when we request permission in viewDidLoad, it actually is an asynchronous request, so our viewDidLoad method will leave scope. Meanwhile, iOS shows the request or shows the alert requesting permission. And since our viewDidLoad method has left scope, theoretically a local variable, a location manager of local scope could get garbage collected while that alert is up. If that happens, iOS will have some very hard times and our app might actually end up crashing. So to save all that trouble, we'll make sure that the CO location manager stays in scope the whole time just by being field level. I'll need a using. And now I can actually add the code to request. Now remember, these APIs are only available on iOS 8 and above. So we're going to go ahead and check our system version to be at least 8. If that's true, then we will request when in use authorization. Now, of course, when we request when in use authorization, that alert dialog is going to show up asking for our app to have permission to access the user's location when our app is in use. That alert dialog will also have text that we can supply in it. We supply that text in our info plist. So let's open that up, go to our source, and then add a new entry down here. NS location when in use usage description. And then the value, we'll just set this to improve search results. All right, let's double check, make sure we spelled that perfectly. NS location when in use usage description. All right, that looks good. And now we can, of course, modify our map in code, or we can just go back to our storyboard, select it, and tell it that we want to show user location. Let's go ahead and re-enable these properties again that we disabled during the last step of our last exercise. And let's give it a run. All right, so as soon as we opened our app and opened this view controller, of course, just as expected, we got our permission request here. And it says, allow map app to access your location while you use the app. And then in subtext there, improve search results. Maybe I should have said to improve search results. That might have been slightly better, but this works for now. And so we're going to go ahead and allow it. And that means that we're able to get the user's location. And our simulator settings right now have us on a freeway drive. And if we were to zoom in, we'd see that it's moving around a freeway in the Bay Area. Ever so slightly moving down that highway. So we've got our happy path working, but what happens if the user declines to give us permissions? Let's go ahead and modify our app's permissions in the setting apps. Go to privacy, location services. There's our map app, and let's change that to never. And now we'll go ahead and debug our app again and see what happens. No user location. So our map still works, but this is kind of disappointing, and we want to see if we can handle this a little bit more gracefully, actually encourage the user to change their mind. Let's get back to our view controller. And if we're going to have the user change their mind, we're going to actually want to ask them once they're already seeing that we have a map up. That might help convince them that location data and sharing location data is a good idea. So we'll put this in view did appear rather than view did load. In view did load, they wouldn't be seeing our map yet, so they wouldn't maybe be encouraged to share location. So instead, we'll put it in view did appear, and they'll be seeing the map in the background when we have the chance to ask them, please, 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 would you please share your location data? All right, so first thing we're going to do is see if, in fact, location data was not shared. So CL location manager dot status, and see if it was denied. We're going to need some more space in here, so I'll give a couple line feeds. All right, now if it was denied, we have a few options, right? We can just ask the user, please go to the settings app and please change it. Or if they're on iOS 8 or above, we can actually open the settings app for them. And so what we're going to do now is actually check to see if they're on 8 or above. So just like we did before, we'll check our system version. Now if they're not, then we're just going to do the pretty please go to your settings app. And so here we'll do var alert equals new UI alert view, and we'll say unable to determine location, and then we should put a lot of explanatory text about what we really need, but for right now we'll keep it short and just say please go to settings and fix this pretty please. And then we don't really need a handler delegate, and we want our OK button to be the one that closes this, and then we'll just show the alert. So that's really all we can do in our non-iOS 8 circumstances. Just explain to the user what's going on and then say pretty please. In iOS 8, we can also first say pretty please, and if they say OK, we can then actually direct them to the settings app ourselves. So let's actually look at doing that now. Let's create a UI alert controller for the finer handling of this. We'll say pretty please again, but this time we'll actually offer to open the settings app for them. And we want the alert style of display here. Now let's add a response action. In the yes case, we want to actually open up the settings app, which means first getting the URL string for the settings app, turning that into a URL, and then opening said URL. Now we're still counting on the user to actually make the changes that we're asking them to make, so we better make this string up here convincing, but at least we can make it less difficult for them to actually do so. And then we just need to handle our no action as well, which means just closing the alert. And lastly, present our yes no alert controller. Okay, before we debug this, let's make sure that our app isn't running. Command-Shift-H, and we'll just kill map app here. And come here and start again. Remember, we still don't have permission. However, even though we can't get the built-in dialog box to show again, we can detect it and show our own dialog box. So we've got it. Can we open the settings for you and you'll change it? Pretty please? Why, yes. Yes, I think I will allow that. And here's our settings app for our specific app, our settings page for our specific app. And now I can click this, say while using the app. And then thanks to iOS 9, I even have this nice back to map app button here. And when I come in, sure enough, I can now see my user location. So we talked about how we can work with our device's location, how to deal with privacy concerns and privacy settings, and how to show the current location on the map. So now let's see how we can adjust the viewport of our map. We're going to start by looking at the MK Map Camera class, and that's going to be the central unit of dealing with this viewport. And then we'll define the camera's view, set the properties on our camera, and then show different regions on our map. We've already seen that by setting specific properties on our map, our users are able to adjust our viewports. Our users are able to zoom, able to scroll. Well, now we're going to look at just adjusting those things ourselves. We do that through our MK Map Camera. Our MK Map Camera is the virtual camera that kind of represents our eye or our lens looking out at the world, looking out at our map. We can use it to change our heading, change our rotation, change our angle, or change our elevation. We refer to the drawn area from the camera's perspective as the viewport. So we're going to configure several different settings in order to get just the viewport that we want. Our center coordinate is pretty obvious. Our heading, our altitude, and our pitch are also things we're going to look at. So that center coordinate, well, that's what we're looking at. That's the point on the map that we are centered on. Our altitude ends up controlling the level of detail we see versus the big picture. So if we're very, very close, if our altitude of our camera is very, very near, then we're going to see high detail, but not a big picture. For instance, in this one, we can see that on the right side, we see only small portions of Kansas and Oklahoma. However, if the altitude of our camera is very, very high, as in the left picture, we see like 7 states. Our pitch, on the other hand, controls the angle at which we're looking at the map. So our default pitch shows a top-down view, and we're looking basically perpendicularly overhead on a map. However, as values get higher and higher, values go away from 0 for our pitch, we start being closer and closer to looking along the map, to actually having a camera angle that's sitting on the map. And finally, our heading controls what direction we're looking. So by default, we're looking in the north direction, and that's a 0. We can change that value to, for instance, 180, and we'd be looking southward. We can make these changes directly on our map. There's a camera property, and right there we can start making these changes. Change the altitude, change the pitch, the center coordinate, and our camera will move. Be aware, however, that if we do it that way, or if we just set the camera property to a new instance of a camera, that our camera will jump. It will instantly go directly to the new coordinates and new settings. If we want it to animate to those new settings, if we want it to slide over to the new settings, then we're going to be using the set camera method. So we'll do map.setCamera, pass in our new MK Map Camera instance, and then set the animate parameter to true. All right, let's check this out in an individual exercise now. Okay, for this next exercise, we will not be continuing with the same solution from the previous exercises. We're going to go through to our downloadable materials, check out our Part 3 resources folder, and in there you'll see a Start folder. Now this solution is very, very similar to the one we've been working on. We just changed the buttons up a little bit. So let's open up that solution. And then let's just hit our debug or play button and take a look at what I mean. And here you can see a very, very similar project, just different buttons with San Francisco misspelled. Let's not worry ourselves about that. Let's go ahead and hit stop and implement those buttons. So open up your view controller and scroll down a little bit and you'll see that sure enough we have button handlers. We will also need to get the locations of these cities here. So let's go to our start here.html and then inside there our exercise 3 and scroll down until we find this code right here. And we're going to make those field level variables in our class. That way we don't have to go and find the exact latitude and longitude of all these cities. Okay, so now that we've done that, let's go ahead and code up San Francisco. We're just going to reset the existing camera to be centered over San Francisco. And for Boston, we'll do something very similar, but we'll explicitly set the map type here for Boston. Now notice how we're setting the pitch explicitly for Boston, but not for San Francisco. That's going to have some side effect when we actually look at how the buttons work. San Francisco, because it continues using the existing camera but doesn't reset the pitch, is going to end up always showing San Francisco with whatever the last used pitch was. On the other hand, Boston is resetting it explicitly every time. And then for Boston, we'll also make sure that we have show buildings set to true. Now, this is not going to work on our simulator. However, if you run this code on a device, then you're going to see that our buildings show up just like we see here. Okay, this will not work, however, unfortunately, on our simulator. All right, and then for London, we're going to do things a little bit differently. We're going to actually create a new instance of the camera. And that means, of course, that it won't end up inheriting any of the properties from the previous button clicks because it's a brand new instance of the camera. That said, we're not using set camera though, so it's still going to change the camera instantly. It's not going to animate to the London location. And we're setting the heading to 180, which means we're going to be looking southward over London. Finally, with Singapore, we're going to actually use a camera variable. And once again, it'll be south facing. With that camera variable, we can now use set camera, and we'll see that going to Singapore will be animated. All right, we've got our buttons enabled. Let's check this out. Okay, so first up, our misspelled San Francisco. We can see we're centered over San Francisco, looking directly down. No pitch to it. Let's check out Boston. Now Boston, we can already see the pitch because we could see those lines, how they were converging in the distance. That's because of the pitch that we have. Now if we had buildings enabled, well, actually we do have buildings enabled, but if we were running this on a device where it could actually render those buildings, we'd see the three-dimensional buildings, just like we did in that screenshot. Now that we've reset our camera to being at a 45-degree pitch, and since San Francisco doesn't reset the pitch at all, let's see what happens now when we go back to San Francisco. A completely different look on it. We can see Fisherman's Wharf up here in the distance. Okay, let's go to London. And notice we still jump there. We still have a 45-degree angle here, but now we're looking from a northern camera position looking towards the south. So we're looking towards the south of London. And again, let's look when we go to San Francisco how we have a completely different view on San Francisco now. Now it's almost like our camera is standing on Fisherman's Wharf looking southward. Okay, and then finally, let's take a look at Singapore. We're going to actually animate towards Singapore. Now, the animation isn't that interesting when it goes this far, this fast, because the map can't actually download the tiles that fast, and so we just end up seeing that grid flyby. All right, but here's Singapore, and there, interestingly, is IKEA dead center in the middle of Singapore. Okay, so we've seen now how to modify our viewport in a few different ways. Let's go back to our slides. Another option we have for setting our viewport is the older set region method. Now, set region is not quite as flexible as our camera method and our camera APIs. However, it does have some advantages. For instance, if we know exactly the region that we want to display in our viewport, we don't have to guess at what altitude is just the right altitude to get that framing. So for instance, here we just use a from distance and pass a center point. There are other methods, however, for getting an MK coordinate region, and you can consult the documentation to find lots of them. After that, we'll just call set region, and yes, this one also has an animate parameter available. Ultimately, however we get our MK coordinate region, we're getting a center point and a span. The center point obviously is the center point of our map. The span is actually the difference in degrees, or the distance in degrees, from our center, both vertically and horizontally. Now, it requires some math in order to be able to do the calculations you need to do, since that's in latitude and longitude. However, if you go ahead and Google and get that math, you're going to be able to do some pretty precise work with the map, and that can be really useful under certain circumstances. So now we've seen that our user can modify our viewport, and we've seen that through code we can even modify our own viewport. Either way, if our viewport changes, we can actually find out because we can tap into the region changed event. We can subscribe to that event, and as you can see here, we even have the opportunity to intercept the event and, for instance, make sure that the altitude stays below 100. So in this section, we've seen how to modify our viewport directly using either our MK map camera or regions, and we've even seen how to subscribe to the region changes. Now let's look at adding annotations to our map. We'll look at what is an annotation, how to add them to our map, how to change their data, and finally how to remove them from our maps. So what is an annotation? Well, it's the graphical indicator we use to point out a specific location on our map. Of course, the default is that pin annotation like we see on the left. We can, by the way, also include those callouts, including a title and subtitle. On the right, you see that we can even do a completely custom annotation, and we'll learn how to do that in IOS231. Yes, those two can include the callouts with title and subtitle. But for today, we're going to focus on the pin annotation like we see there on the left. All of our annotations derive from the MK annotation abstract base class. The MK annotation base class is actually our implementation of iOS's MK annotation protocol. The MK annotation base class, therefore, ends up providing most of the model data about our annotations. Importantly, including coordinates, like you see with our MK point annotation here. So MK point annotation is an implementation of MK annotation, and it's the one that we typically use when we want to show a pin in our map. So here, we're setting the title, subtitle, and of course the coordinates, that is where it's going to show up on our map. After we've created that MK point annotation, we'll just call add annotation to add it to our map's annotations collection, which, as we can see here, is just a collection of the previously added annotations for our map. If we want to change the location of an annotation at runtime, that's no problem. We just change the coordinate property. We can also change the title and subtitle properties. However, be aware, if we did not have a title to begin with when we created that pin annotation or that point annotation, we probably won't be able to get the callout. The callout will be disabled when we create the pin without the title, and it will stay disabled even though we actually end up setting the title later. We can remove annotations pretty much as easily as we added them. you might even say more easily, we just pass the reference to the remove annotation or remove annotations if we have multiple. Note that we do need the exact reference. Also note that I have both a remove annotation and a remove annotations plural version. Add also has that pairing, so we have an add annotation, and if we have multiple annotations to add at one time, we can use add annotations plural. Finally, we're able to make sure that all of our pins are visible on the screen at one time. By calling show annotations and then passing a collection of annotations that we want visible, the map viewport will scroll, adjust, zoom, or unzoom as necessary to make all of our pins fit in the screen all at one time. And of course, if we want that to be animated, we'll set the parameter to true. Now let's do an exercise where we'll add the annotations to our map. Alright, in this final exercise, we're going to add annotations to our map. We're going to once again start with a similar but different project. So let's go to Part 4 Resources and the Start folder and open up this version of mapping.sln. I'll close my last version there. And here, once again, we're going to want to go to our View controller. And just to take a look real quick, let's see what it looks like to start with. As we can see, largely the same project, just with different buttons. Add points and remove points. So these will be to add our pin annotations and remove our pin annotations. As we can see, our locations are never used yet. Let's fix that. We've got two button handlers for activated and removed, or added and removed. When we want to add our points, we're going to do something like add annotation loc San Fran, and then we'll give it a title, San Francisco, spelled correctly. And we'll say fog and Xamarin HQ because that's what our exercise files tell us is the correct subtitle. Now, I don't yet have an add annotation method, but I want one. Let's put that right down there, and I'll implement that momentarily. Let's add our other annotations, though. I want loc Boston. Okay, finally, let's disable and enable our buttons as appropriate. And then let's go implement add annotation. So the first thing we'll do is fix our parameter names that were auto-generated here. And next up, let's create that annotation. We want an MK point annotation. And of course, then we have to actually add it to our map. Okay, lastly, let's implement our remove. We're just going to call map.removeAnnotations, and we'll pass the collection of the entire set of annotations. Then, of course, we need to modify the enabledness of our buttons. All right, that's all there is to it. Let's take a look. No points. I hit add points and we get a few. Let's check out London. Let's check out Singapore. And remove points. All points removed. Let's add them one more time and check out our title and subtitles. Boston, get a donut and coffee. San Francisco, fog and Xamarin. All right, that's all we do to get our pins working. And that's it for our annotations. We've seen what they were, how to add them, how to change them, and how to remove them. Next up, let's look at iOS 231, where we'll work with custom annotations, custom callouts, and look at other things with our location APIs. All right, that's it for today. Thank you very much for viewing this iOS 230 recording. I look forward to seeing you in future live classes. I'm Jason DeBoover. Goodbye.